Welcome back to VMware View Administration Training. This time we're going to talk about creating ThinApp packages. In this lesson, we'll talk about how ThinApp works to virtualize applications. We'll talk about some of the requirements and limitations that ThinApp has when packaging these applications. Then we'll talk about the best practices for the machine that we use for packaging. We'll go through the steps that it takes to virtualize an application, and once that package is created, what its pieces and parts are. We'll cover a few of the advanced topics of ThinApp, but won't be able to dive too deep into them. And then we'll talk about how you can test your packages. We'll wrap up by actually walking through the packaging of an application, specifically Firefox. So let's jump in. So ThinApp actually provides a layer of virtualization between the OS and the application itself. This is very similar to the way VMware is able to virtualize the hardware away from the operating system. As part of this virtualization layer, it partially isolates the applications from one another and from the operating system itself. When you execute a ThinApp package, it actually runs under the user's context within Windows. This allows us to be able to push applications and execute them without having to have any special permissions within Windows. When you execute a ThinApp package, it creates a bubbled environment. This bubble contains a virtual file system and a virtual registry that we as administrators can select whether it'll merge or completely replace the operating system, file system, and registries. This is the key to the isolation that ThinApp provides to our applications. As part of this isolation, ThinApp creates a sandbox location where any changes we make while in the application will be written to. When creating the package, you can choose the permeability of this bubble and determine what goes into that sandbox and what can write directly to the operating system. You also define the permeability to determine what the application can see within the OS and registry. A great example of this is when we're running Office 2007 natively installed within the operating system. If you want to start testing Office 2010, without this virtualization layer, you would have to uninstall 2007 and reinstall 2010. If we were to package Office 2010 using ThinApp, we could use this permeability to prevent the Office 2010 application within the ThinApp bubble from seeing any other registry or file system locations where Office 2007 would write any data, thereby tricking Office 2010 into thinking that Office 2007 is not present in the operating system, allowing you to run both applications side by side. When we create the package, we'll create it on an operating system that would be our lowest common denominator. In other words, the oldest operating system we would want to support. By packaging it this way, we ensure that the application, when it's installing, it will add any files during the installation that the application requires. This will mask any files that may exist on other operating systems that execute this package. You occasionally will run into an application that will have a difficulty running on a Windows 7 machine after being packaged on Windows XP. But generally speaking, it'll work after packaging on Windows XP and running it on Windows 7. The package itself is actually comprised of either a single executable or a series of executables and potentially even a DAT file, depending on the size of the application and the number of application entry points that exist within it. The entry points are created to provide access into the bubble. This could be a single executable like you would have with Firefox, or it could be multiple executables like we would have in Microsoft Office, where you would have a Word entry point and an Excel entry point. During the packaging process, you get to choose which entry points will be available to the end user. Here are some of the requirements that ThinApp has. It can be run on a 32-bit operating system that's at least Windows NT. This would include Windows NT, Windows XP, Windows 2000, and above, including both the desktop and server operating systems. When executing a ThinApp package on a 64-bit OS, you'll need Windows XP or Windows 2003 or above. Again, both server and desktop operating systems. You can package 16-bit applications, but they must be run on a 32-bit version of Windows. When packaging 32-bit applications, you can run them on either 32-bit or 64-bit Windows. And finally, when deploying a ThinApp package, you can deploy it to both terminal server and ThinApp, and publish them like you would any other application. So that's what it takes to run ThinApp. Let's talk about what limitations you'll run into with it. First of all, if you've packaged an application with ThinApp and try to deploy it to an operating system that application doesn't support being natively installed on, odds are it won't work. I have seen it work a few times, but generally you're going to have some problems. Since ThinApp runs under the user's context in user mode within Windows, any application that requires a kernel mode device driver is simply not going to work. ThinApp won't even pick up that driver. This will include items like antivirus, VPNs, and firewalls. ODBC drivers are the one exception because they actually run in a user mode context. And scanner drivers and print drivers generally don't work either. When packaging an application with ThinApp that provides shell extensions to Windows, not all those shell extensions are going to work properly. This is due to the nature of the high integration these applications provide with Windows that a ThinApp bubble simply can't replicate. When using applications that utilize COM and DCOM, these interfaces will only be available within the bubble, so applications that are running outside of the ThinApp bubble won't be able to make connections to these services. Network-based DCOM simply won't work at all. ThinApp does not support 64-bit applications inside the bubble, and it does not support 16-bit applications running on a 64-bit OS. So when building a ThinApp package, you do it on a packaging machine. And here's a few best practices when creating that machine. First of all, it's highly recommended to use a virtual machine because they tend to have less drivers installed and less issues with the install of the application, which could lead to an easier installation. Plus you have the capabilities of using snapshots, which are an invaluable tool when using ThinApp, because you can easily install an application and then immediately revert the snapshot back and test that application, revert it again, and you're ready to package the next application. When using a virtual machine, you can choose to either use vSphere virtual machines or Workstation virtual machines. When purchasing ThinApp Packager licensing, you actually do get a license of VMware Workstation along with it. Like I said earlier, you want to use the earliest OS that you're going to support these ThinApp packages on. In most cases, a Windows XP Service Pack 3 machine will be sufficient. I don't know that many environments have desktop operating systems lower than that. And if you're using ThinApp along with a View deployment, that's the lowest operating system View will support anyway. You want to make sure that this operating system is as clean an install as possible. This means installing as little software as you possibly can. I typically leave off antivirus software, any sort of defrag tools, Java, .NET. The idea here is that ThinApp works using a pre-scan, post-scan process. So any items that exist in the pre-scan won't get captured as part of the application. And if one of these other pieces of software is already installed and happens to install a DLL or executable that this application relies upon, and that DLL or executable doesn't exist on the machine we deploy this ThinApp package to, then that application simply isn't going to work. So by having as little in the image as possible when doing our pre-scan, post-scan process, we'll ensure that as many files as necessary are captured inside of the package. What I typically do is simply install the Windows updates, ThinApp, and nothing else. The one place where I actually do install applications beforehand is when I know this application will be installed in the base image every single time. This machine can be a member of the domain, and I recommend it because it actually makes accessing network shares easier. And as a best practice, you generally want to store most of your ThinApp files out on the network. If you are going to add this desktop to the domain, I would do it before you take the base snapshot that we'll revert back to for our clean machine. And since we'll be reverting this snapshot quite often, we don't want the computer account password to be changed. So I recommend setting the computer account within AD to never expire the password. So now let's go over the actual steps that it takes to virtualize an application. Again, start with a clean operating system with ThinApp installed and a snapshot taken. Then you execute the pre-scan, which catalogs all the file system and all the registry within that machine. This is another reason why I recommend having as clean an operating system as possible, so that the cataloging process goes a lot quicker. If you have a large file system, it's going to take a lot longer to do the pre-scan. Next, you install the application, including any configuration or testing of that application that you want to occur and be captured in the package. After all that's complete, you do the post-scan, which again catalogs the entire file system and registry, and then does a comparison between the post-scan and the pre-scan to determine what files the application added to the operating system. Then you go through a wizard where you can configure the ThinApp package itself. We'll go through all these configuration items during the walkthrough of the ThinApp process. Then ThinApp is going to copy all the files that it found between the pre-scan and the post-scan out to a project directory. This gives us the ability to directly manipulate those files and registry settings, along with the configuration of the package itself, which is partially configured during the wizard. Finally, we build the package, creating that executable or series of files. So once that package is built, what do we have? We have a virtual registry, which in the project itself is represented by 3 text files. We have a virtual file system, which is laid out very nicely in the project for us to manipulate after we've completed the ThinApp wizard. Scattered throughout the file system of the project, we'll find an attributes.ini file. This file will define for each directory what its permeability is set to. There'll be a package.ini, which is our main configuration of the ThinApp package. Any items that we set during that wizard will also be available to change in the package.ini, along with a lot of other settings that we won't even discuss during this lesson. For each package, there's 1 or more entry points. These are the executables that users would double-click on to launch the ThinApp package and create the bubble. There's a primary data container, which can either be a part of one of the entry points or a separate DAT file of its own. There's the sandbox that contains all the changes the user makes while inside of the bubble. And finally, you have the option of creating an MSI package, which can be used for deploying the ThinApp package. ThinApp is a very robust tool, and covering all of its details is far beyond the scope of this lesson, or this video series, which is focused primarily on the view aspects. So I want to lay out a few of the concepts of ThinApp that you can dig into. First of all, within the package.ini, there's a series of different settings that you can configure. The first of which is the app link functionality. There are 2 different app links you can configure, an optional and a required app link. App linking is used to take 2 ThinApp packages and merge their bubbles at execution time. This provides us the capability to create 2 separate packages, one for Firefox and one for Adobe Flash, but be able to merge the 2 together when we execute the Firefox package so that we have Flash capabilities within that bubble. For the sandbox location, there are many settings that we can define, including the name of the sandbox and the location of the sandbox. AppSync gives us the capability to update packages that have been deployed outside of the central network location that we store our package in. This can be useful for people that run ThinApp packages on their laptop outside of our network. It works by defining a URL that the package needs to contact every time it launches. In that URL, we can place the updates, and the package will automatically find them, download them, and apply it to the local copy of the ThinApp package. We can define the configuration of the MSI package that gets created. And any other settings that we configured during the setup capture wizard are also modifiable within the package.ini. This is great because if we find a setting that we set improperly during the capture process, we don't have to go through the entire capture process all over again. We can simply go in, modify the package.ini file, and rebuild the package. Isolation settings define the permeability of the bubble. They can be modified in either the package.ini file, which defines the defaults, or in the attributes.ini files, which defines them for individual directories. There's also capabilities to modify which registry keys are permeable through the bubble as well, which is important when trying to do a side-by-side installation of 2 different versions of Microsoft Office. A useful utility for managing ThinApp packages is the sbmerge utility, which can be used to rebuild a package based on changes that are captured in a sandbox. This becomes really useful when we want to update a package with new patches. We can simply take a clean machine, execute the ThinApp package, complete the update within the application, shut down the application, and run SB merge to take that sandbox location and shove it together with the package itself, creating a new package that has all of the updates already applied. We can then deploy that package out to everyone, providing them with the new updates. And finally, we can define scripts within ThinApp to modify how the package works during runtime. This opens up a world of possibilities that only scripting can provide. Once we have our package created, we need to test it before deploying it to our end users. The first test you can run is called a dirty test, which is simply running the ThinApp package on the same machine that you use to package the application. They call it a dirty test because all of the files and registry settings that the application needs to run already exist within the native operating system. So it prevents us from finding any files or registry settings that may be missing inside of the package. After performing the dirty test, we can uninstall the application from the packaging machine and run the package again. This provides us a higher level of confidence that the application was properly captured. But if the uninstall leaves behind any files or registry settings, this could throw off our results. To perform a clean test, we would then revert the snapshot of our packaging machine, taking it back to that clean state before the application was installed. We can then execute it there, which will ensure us that anything the application needs to run is inside the package. Our final test is to do it in a production test, using an actual desktop. This could be our view infrastructure, or it could be someone's physical workstation. This allows us to test the package out in the wild, rather than on a clean, sterile machine that we use for packaging the applications. It also allows us to find out whether group policies will affect this package or not. So that's the life cycle of creating a ThinApp package. But to truly get the concept down, it's best if I show you how to do the packaging. So let's do that right now. This is our ThinApp packaging machine. It's a virtual machine that exists within my vSphere infrastructure. It currently has a snapshot that includes Windows XP Service Pack 3 and all the most current security updates. It also has the ThinApp Setup Capture Wizard installed. I also created two shortcuts on my desktop that go to the projects directory and the packages directory, both of which are on an NFS share on my NAS device. The only change I've made so far to my clean image is to download the Firefox setup for version 4.0.1. This is the application that we're going to package using ThinApp. It may not be a popular option within the enterprise, but it is a quick and easy install that can show off the capabilities of ThinApp. So let's go ahead and kick off the Setup Capture Wizard. First thing you'll notice is a little launch up window that appears at the bottom. This is because the ThinApp Capture Wizard is actually a ThinApp package itself. But we'll see that a little bit more once we've built our Firefox package. The welcome screen gives us a lot of information. It'll give us a quick start video that we could watch to show us the steps of creating a ThinApp package. It also gives you a quick table of contents for the steps that this wizard will take us through. It gives us a link to the community site for ThinApp, and it also gives us the version that we're going to be using for this package. Finally, we have a help button that allows us to access the online help. So let's kick off our setup capture. The Ready to Pre-Scan screen gives us some information about the pre-scan and why it's important to use a clean Windows system. The Advanced Scan Locations allows us to define exactly where we want to be scanning. Remember that this scan simply catalogs the file system and the registry. Using this screen, we can define what areas of the registry and the file system that will be scanned. We're good with the defaults here, so we'll cancel out. We'll proceed with the pre-scan by clicking the pre-scan button. Now watching the scan location, you'll see it crawling through the different directories on our file system and the different hives within our registry. Now that ThinApp is done scanning our system, we can install the application. We don't want to click the post-scan button until after we're completely done with our installation, including any reboots, configuration, and testing that may need to be completed before capturing the image. We also have this Internet Explorer button. This will allow us to include Internet Explorer as part of the package. This can be useful because it can actually harvest out Internet Explorer 6 and use it within a package. This allows us the unique capability of deploying Internet Explorer 6 to Windows Vista and Windows 7 desktops. We don't need that for this one, so we'll cancel out. Now the setup capture at this point has saved the catalog to the hard drive of this machine. So if we needed to do reboots or simply wanted to close this setup capture screen while we're doing our install, we can do that. The next time the setup capture wizard runs, it'll actually look for that catalog, and it'll find it and ask us if we want to continue. But for now, let's go ahead and install Firefox. So we'll simply click Next through the installation for Firefox, as we don't need to customize anything. We've successfully installed Firefox now. I'm not going to do any customizations within here, but this would be the time to do those customizations. Also note that there's a shortcut on the desktop that's been created, and also one within the Start menu. We've now successfully installed our application, so we need to continue with the post-scan process so that ThinApp can determine what changes were made during the installation. Since we closed the Setup Capture Wizard, let's go ahead and relaunch it. Where it'll ask us if we want to continue with our current installation or start a whole new capture process, which will of course delete the pre-scan snapshot. This is the snapshot that was created when we ran our pre-scan earlier. So let's continue. And it takes us right back to the Install the Application step of the wizard. We'll go ahead and click Post-Scan, where it'll give us a warning to make sure that we're completely done with the application installation and configuration. We're good here, so we'll click OK. And now you'll see it scan the registry and the file system again. Once the post-scan is completed, the Setup Capture Wizard is going to show us a list of all the executables that it found within the package. The checkboxes on the left side here provide us the opportunity to define what entry points we want to have into this package. For Firefox, we really only need one entry point. That's the main application executable itself. If we were installing an application such as Microsoft Office that has multiple applications inside the suite, we would want to check multiple executables here to allow for multiple entry points for the different applications like Word and Excel. The Show Entry Points for debugging added in two additional executables, command.exe and regedit. We can add these as entry points, which will give us troubleshooting endpoints into the bubble that this ThinApp package will create. Right now we don't need those, so we won't add them in. But they are useful if you find that you're having problems with a ThinApp package. You can come back and recapture it using those debugging tools. I also want to point out at this point that along the process, the ThinApp Capture Wizard does a good job of providing additional information about what the step is asking for. Feel free to use this information as you go along and produce your own ThinApp packages. On the next screen, we can define what groups are authorized to run this particular package. Using this feature, we can actually choose Active Directory groups, and when executing a ThinApp package, the user will be checked to make sure they're part of that group before the package will execute. This is a good way to lock down applications that have stringent licensing requirements. Photoshop is an expensive application, but if you package it through ThinApp, it makes it easy for anyone to be able to execute it if they can get a hold of the package. By defining a specific Active Directory group that has access to this package, you can ensure that only the people that you add to that group will have access to the package. Additionally, when creating the package, ThinApp actually gets the GUID of that group and embeds it inside of the package. This prevents anyone from being able to take this package home, create a group identical to the name that you used, and try to execute it inside their own domain. But for Firefox, we want to allow everyone access. So we'll stick with everyone and click Next. Isolation mode is the setting that defines the permeability of the bubble that ThinApp creates. Full write access, or merged isolation mode, works best for well-written Windows applications. What do I mean by well-written? Well, ones that actually follow the proper rules of using variable name paths for addressing user data, app data, and other core directories within Microsoft Windows. This mode will allow the application running inside the ThinApp bubble to have more access to the desktop operating system. Restricted write access, or write copy isolation mode, prevents the application from writing to almost all the directories. These are good for applications that might write directly to the C drive. The only directories that are allowed to write outside of the bubble will be the desktop and the My Documents directories. Everything else is redirected to the sandbox. Firefox is a well-behaved application, so we'll stick with the full write access and click Next. Now we get to decide where the user's sandbox for this ThinApp package will exist. We could choose to use the user profile, and it puts it in the app data thinstall directory. We can choose to save it in the same directory as the application, which is good for use with a USB or portable media deployment. We'll talk more about deployment in another lesson. Or we can choose to store it in a custom location, which provides us the ability to store it out on a network drive. Since we have the users configured to use redirected folders, we'll use the user profile directory, since this directory will be redirected out to the network already. Clicking Next will take us to the quality assurance statistics step, where we can define whether or not ThinApp will send anonymous data of the application and its usage to VMware. This feature helps VMware to better understand what applications are being ThinApped, how well they work within the ThinApp bubble, and provide them some anonymous data with which to help improve the product. We'll go ahead and say yes to this, since overall it will help VMware create a better product. And we'll click Next. The unique feature for ThinApp is a feature called ThinDirect. The Setup Capture Wizard has detected that we're packaging a web browser. Since we're installing a browser into this ThinApp package, we can configure ThinDirect to hook directly into Internet Explorer within the Windows machine that we run this package on. Once these hooks are in place, we can define web pages in this box that will automatically be redirected from Internet Explorer to this ThinApp package. This feature is particularly useful when packaging Internet Explorer 6, so that we can list websites that are known to only be compatible with IE6 to be redirected into IE6 and not use the native Internet Explorer 7 or 8 that may be used when the users are connecting to a Windows Vista or Windows 7 virtual machine. We'll go ahead and enter TrainSignal's website. Since TrainSignal.com is optimized for Firefox instead of Internet Explorer. And we'll click Next, which will take us to the Project Settings screen. The first setting we have on the screen is the inventory name. This is the name that will show up on cataloging products, like Microsoft's System Center Configuration Manager, that will catalog the applications that are being used on each individual desktop. This name will also be used when creating the sandbox location. So it's important to name this properly in light of any upgrades we may make to the package later on. For now, we'll leave it using the default. The next setting we can choose is the project location. The project location is the place where all the files that are found in the difference between the pre-scan and the post-scan will end up at. We've set up a special project location out on our NAS server, so we'll go ahead and select that, which I've mapped to the T drive. I've created a packages directory to store all of our end packages after we're completed with the ThinApp packaging process. This is the directory from which users will access the ThinApp applications. I've also created a projects directory for us to store all the projects. I recommend putting the projects out on the network share as opposed to the default location on the C drive. This allows us to access the project directory even after the VM has been reverted. So we'll go ahead and select that and click OK, and then click Next. Continuing with package settings, we can choose the primary data container. By default, ThinApp is going to create each entry point as its own small executable. But all of the files and registry information that we captured as part of this process needs to be put into a file. We can choose which one of the entry points we selected early in the process, or we can choose to place it in a separate DAT file. The main reason for using a separate DAT file is if the application installation is particularly large. By default, the Setup Capture Wizard will automatically choose which option will work best for this particular package, so we'll leave it at the default. This will provide us with a single executable that will represent the entire package for Mozilla Firefox. Next, we can choose whether or not to generate an MSI package. We'll talk more about the MSI package and where it's useful in the lesson on ThinApp deployment. Finally, we can choose whether or not to compress the virtual package. This will reduce the space required on our nav server for storing the package. This compression doesn't really slow down the execution of the application very much, but that comes at a cost of a longer packaging process. So the recommendation is to wait to enable compression until after we've had the opportunity to thoroughly test this package to make sure that it works 100%. So we'll leave it unchecked for now and click Save. Now ThinApp is saving off all of the files and registry information out to that project directory location that we defined. Now that this process is complete, we get several options. First, we can edit the package INI. Let's take a look at the package INI. The package INI is a simple text file that defines the configuration for the package. Inside this package are many different settings, and some settings that aren't in here by default are available and documented in the ThinApp User's Guide. All of the settings that we went through on the Setup Capture Wizard are also in this file, like the compression type, which is currently set to none, and the default directory isolation mode, which we set to merged. There are a lot of settings in here, and I highly encourage you to refer to the ThinApp User Guide on what they all mean and how to use them. You will also find a lot of great information out on the community site, including some that may not be documented in the user guide. For now, we'll go ahead and close this out. From here, we can also open the project folder. In here, you'll see ThinApp has automatically created a number of file system directories where it stores all the files it found during the post-capture process. We'll also see a text file that represents each of the major registry hives. And here's also our package.ini file, and a ThinDirect text file that defines all of the websites that we want ThinDirect to redirect to this package. And finally, we have a build.bat file. What this file does is to actually execute the process of creating our package, which hasn't been created yet. Let's switch back to our Setup Capture Wizard. You can also choose to skip the build process, which you'll see the build button on the bottom right changes from build to next once we check this. We want to go ahead and build at this point, so we'll uncheck the skip the build process and click the build button. Then you'll see all of the output for the build process. This is similar to the information you would see if you directly executed that batch script that we saw in the project location. And now our build is complete. The checkbox you see here will automatically open up the folder that contains the package that we just created. So let's click Finish, and you'll see that we have a single executable that represents the entire package of this virtual machine. We also created an MSI file, which allows us to deploy this virtual application. This is the step at which we would do a dirty test. And it's called dirty because, as you can see, our local install of Mozilla Firefox is still installed in this operating system. So executing this application right now may work now, but may not work when we do a clean test, because it may refer to files, drivers, or registry settings that exist with the local install, but couldn't be captured as part of the ThinApp process. Let's go ahead and execute our dirty test now. First, you'll see there's a launching Firefox window that pops up. This is to give the user feedback that a ThinApp application has been launched. And now we can see that our application launched successfully. Let's go ahead and revert this virtual machine, and we'll do a clean test. And now we're back on our reverted version of the ThinApp machine. Back to our clean build, which has nothing more than ThinApp installed, and a couple of shortcuts to our projects and packages directories. You'll notice that our Firefox is now missing, and is no longer installed. So let's go ahead and jump into our project folder, where we'll find a bin directory, which contains our Mozilla Firefox package. All we need to do is simply double-click it. We'll see our ThinApp pop up. And now we have Firefox running on a Windows machine that doesn't actually have it installed. And you can see we can now successfully use this package to browse the web. And that's all it takes to create a ThinApp package. Now, of course, there's a lot of additional configuration that you can do with ThinApp, and many applications are not nearly as simple as packaging Firefox. But that should be enough to get you started with creating ThinApp packages and understanding how the process works. So some more information to help you go further with ThinApp. First of all, the ThinApp User's Guide is a large document that contains tons of information about ThinApp, how it works, and how to use it to create your applications. Next, the ThinApp Reviewer's Guide is more or less a quick start guide that will help you get ThinApp installed and up and running, and starting with packaging. Finally, check out the ThinApp community contributed project files, where you can go out and find more information about specific applications and how best to package them. Many of them are written by VMware employees, but some are actually created by end users as well. So we covered a lot in this lesson, so let's do a quick review. We started off talking about how ThinApp works, what it does to virtualize applications, and some of the concepts related to using ThinApp. Then we went over some of the requirements for ThinApp, and some of the things ThinApp simply can't do. Next, we covered some best practices when creating the machine that you'll use to package these applications. What it really comes down to is making sure that you have the right stuff installed inside of that image before running the Capture Wizard. And generally that means having nothing installed at all. Then we covered the actual steps that it takes to create your virtual application using the ThinApp Setup Capture Wizard. Then we discussed what all is part of a ThinApp package and some of the important files that go into making ThinApp work. Then we talked a few of the advanced concepts with ThinApp. We didn't cover them in depth because there's a lot of information there, but I encourage you to spend time inside the user guide and on the forums learning more about them. And we ended our lecture talking about how you test packages and the different types of tests that you can complete in order to test the package once it's created. And we finished up with an actual walkthrough of the packaging process, where I showed you step by step what it takes to create the package and a lot of information about the different steps on the way. So that's all we have for creating the ThinApp packages. Check out the next lesson where we'll talk about how you deploy these packages to your end users' desktops.